Autoimmune polyendocrine syndrome. Definition: Autoimmune polyendocrinopathy syndrome is a genetic autoimmune disease with an extraordinary array of clinical features, but characterized most often by at least two of the following three findings: hypoparathyroidism, underfunctioning of the parathyroid glands, which control calcium; candidiasis, yeast infection; and adrenal insufficiency, underfunction of the adrenal gland.
Autoimmune polyglandular syndrome type 1, also called APS type 1 or autoimmune polyendocrinopathy candidiasis ectodermal dystrophy, also called APECED, is a rare genetically inherited condition. Autoimmune means that the body's immune system begins to attack its own tissues, and polyglandular means that multiple hormone-producing organs are affected. Normally, your body should only react to things that are foreign or not self. This is maintained by a process called immune tolerance, where only non-self-reactive B cells and T cells are allowed to mature, whereas self-reactive ones aren't. For T cells, this process takes place in the thymus, where a gene called AIRE, or autoimmune regulator, is expressed by thymic medullary epithelial cells. When T cells are developing, this gene leads to the production of thousands of the body's proteins, and this serves as a test to see whether the T cells react to self-proteins. If one does, that T cell either undergoes apoptosis and dies, or it becomes a regulatory T cell, or Treg, that helps to eliminate other immune cells that react to self-antigens. In APS type 1, there's a genetic mutation in AIRE that's usually inherited in an autosomal recessive fashion. This means that the thymic medullary epithelial cells lose the ability to display the body's different self-proteins. Since they can no longer test whether T cells are self-reactive or not, the process of immune tolerance does not occur normally, and self-reactive T cells are allowed to live. Regulatory T cells are no longer produced normally either, so the body loses a second mechanism for destroying autoimmune cells. This allows for the production of antibodies and lymphocytes that target normal tissues of the body. It is still unclear why, but certain glandular tissues, including the adrenal glands and parathyroid glands, are particularly targeted. There are multiple characteristic signs and symptoms of APS type 1. One of them is polyendocrine malfunction, resulting in hypoparathyroidism, characterized by low calcium and elevated phosphorus in the blood that can cause muscle cramping and seizures, and primary adrenal insufficiency, also called Addison's disease, which can reduce cortisol and aldosterone levels.
Applications in medicine. In 1997, a novel gene was identified that mapped to chromosome region 21q22.3. The gene was named AIR for autoimmune regulator. Changes in the AIR gene are responsible for the autoimmune polyendocrinopathy syndrome.
Autoimmune polyglandular syndrome, APS. Autoimmune polyglandular syndrome, APS, a genetic autoimmune disease with an extraordinary array of clinical features but characterized most often by at least two of the following three findings: hypoparathyroidism, underfunction of the parathyroid glands which control calcium; candidiasis, yeast infection; and adrenal insufficiency, underfunction of the adrenal gland. APS was the first systemic, body-wide, autoimmune disease found due to a defect in a single gene. By autoimmune is meant that the immune system, which normally wards off foreign invaders of the body, turns and attacks tissues such as skin, joints, liver, lungs, etc., of the body. Examples of common systemic autoimmune diseases include rheumatoid arthritis, systemic lupus erythematosus, diabetes mellitus, Sjogren syndrome, scleroderma, Goodpasture syndrome, vitiligo, Addison disease, thyroiditis, and many others. In 1997, a novel gene was identified that mapped to chromosome region 21q22.3. The gene was named AIR for autoimmune regulator. Changes in the AIR gene are responsible for APS. APS is inherited as a recessive trait such that a child with the disease has received two changed, mutant, AIR genes, one from each parent. Although APS is generally rare, it is more frequent in three genetically isolated populations: the Finnish, Iranian Jews, and Sardinians. The child with APS develops problems in numerous glands, polyglandular, including hypoparathyroidism, hypogonadism, with sex gland failure, adrenal insufficiency, type 1, insulin-dependent, diabetes with insufficient insulin production by the pancreas gland, and latent hypothyroidism, underfunction of the thyroid gland. Other features of APS are total baldness, alopecia totalis, inflammation of the cornea and whites of the eye, keratoconjunctivitis, underdevelopment, hypoplasia of the enamel of the teeth, childhood onset maniliasis, yeast infection, juvenile onset pernicious anemia, gastrointestinal problems, malabsorption, diarrhea, and chronic active hepatitis.
Pros and cons. Pros. The genetic gene responsible for the syndrome has been detected. Cons. It is inherited as a recessive trait such that a child with the disease has received two changed mutant AIR genes, one from each parent.
You were talking to other kids your age about APS type 1. What kinds of things would you tell them?
That you're not that different than other kids. I thought I was different, but really all you have to do is just take medicine, and then you're just like everyone else. Just you have to take a pause from your day. It's not as bad as you think, and then you're normal and you can go run with them like all the other kids.
Heather, was it difficult to get a diagnosis for Gabby?
Yes. At 6 months of age, our daughter decided to come out with a rash. And a doctor couldn't tell us what it was. They said it was just a normal rash and would come and go. And it took basically 11 years from my point of view, 10 years, 6 months, for me to get a diagnosis. That was the start of her, the progression of her disease. So, yeah, it was very tough, and it progressed from there.
Todd, do you have any idea how many people are affected by APS type 1?
Yes, APS affects 1 in 2 million. So, as I always use an analogy, there's 300 million people in the U.S. That would be 150 APSers just in the U.S. alone. So far in the U.S., we probably have contact with about 20. So.
And how have you made contact with those other people?
We started by we started a website, because in the U.S. It's named differently, and that was difficult for us because APASET is known in Europe, but the name is not known here in the States. A lot of the physicians in the States call it APS type 1. The problem was we couldn't find any information on APS type 1, so right after Gabby was diagnosed, we made the decision to start our own website to help people, and that's probably was the start of the initial connections and people finding us and we finding them.
And is there a treatment for it?
No, although we're hopeful that one day they'll, through the research that we're doing, that we'll find one and hopefully a cure. But all you can do with the condition is treat the outcome of what the condition does. So you monitor your antibody level in certain parts of your endocrine system, and when it presents itself, you have to manage it accordingly. It's kind of a very delicate balance.
Gabby?
I just want to say to anyone who has APS that you will encounter a lot of other things down the road. Like my antibodies have attacked my ovaries, they've attacked my parathyroid glands, my adrenal glands. It's just, you just gotta go with it. And you'll find that you'll have to keep adding medicine, but it's just adding medicine. you you get by.
Thank you very much.
Yeah.
Cool.
Issue applied in Ecuador. In Riobamba, the number of cases with glandular diseases has increased a lot in the past years, which is a risk factor for producing autoimmune polyendocrine syndrome as a consequence.
APSers get a variety of different things. None of them are ever the same, but they all have three monikers for the condition. They usually have hypoparathyroidism, Addison's disease, and candidiasis. And usually from there, they build on, and then from there, people get multiple conditions beyond that. So over the years, my daughter has hypoparathyroidism that we learned about this morning. She also has Addison's disease, ovarian failure, chronic tubular interstitial nephritis. It's 1 in 2 million is currently. So if you look at the U.S. population, you could find maybe 150 people. So we have probably about 40 or 50 or so families that we're in contact with at this point.
Conclusion. Autoimmune polyendocrine syndromes comprise a diverse group of clinical conditions characterized by functional impairment of multiple endocrine glands due to loss of immune tolerance. These syndromes also frequently include conditions such as alopecia, vitiligo, celiac diseases, and autoimmune gastritis with vitamin B12 deficiency that affect non-endocrine organs.
Syndrome, autoimmune polyendocrinopathy. Syndrome, autoimmune polyendocrinopathy, a genetic autoimmune disease with an extraordinary array of clinical features, but characterized most often by at least two of the following three findings: hypoparathyroidism, underfunction of the parathyroid glands which control calcium, candidiasis, yeast infection, and adrenal insufficiency, underfunction of the adrenal gland. The autoimmune polyendocrinopathy syndrome was the first systemic, body-wide, autoimmune disease found due to a defect in a single gene. By autoimmune is meant that the immune system, which normally wards off foreign invaders of the body, turns and attacks tissues such as skin, joints, liver, lungs, etc. of the body. Examples of common systemic autoimmune diseases include rheumatoid arthritis, systemic lupus erythematosus, diabetes mellitus, Sjogren's syndrome, scleroderma, Goodpasture syndrome, vitiligo, Addison disease, thyroiditis, and many others. In 1997 a novel gene was identified that mapped to chromosome region 21q22.3. The gene was named F for autoimmune regulator. Changes in the AIR gene are responsible for the autoimmune polyendocrinopathy syndrome. The syndrome is inherited as a recessive trait such that a child with the disease has received two changed, mutant, AIR genes, one from each parent. Although the syndrome is generally rare, it is more frequent in three genetically isolated populations: the Finnish, Iranian Jews, and Sardinians. The child with autoimmune polyendocrinopathy syndrome develops problems in numerous glands, polyendocrine, including hypoparathyroidism, hypogonadism, with sex gland failure, adrenal insufficiency, type 1, insulin dependent, diabetes with insufficient insulin production by the pancreas gland, and latent hyperthyroidism, underfunction of the thyroid gland. Other features of the autoimmune polyendocrinopathy syndrome are total baldness, alopecia totalis, inflammation of the cornea and whites of the eye, keratoconjunctivitis, underdevelopment, hyperplasia of the enamel of the teeth, childhood onset moniliasis, yeast infection, juvenile onset pernicious anemia, gastrointestinal problems, malabsorption, diarrhea, and chronic active hepatitis. SYNDROME